Namaste. In the previous class, we looked at few reactions which involved distinguishing between an aldehyde and a ketone. The distinguishing test is basically based on the mild oxidation of aldehydes and strong oxidation of ketones. We looked at two specific cases, Tollens test and Failings test. Tollens test is also called as the silver mirror test because silver, which is in initially in the form of a black precipitate, gets deposited on the surface of the test tube or the flask in which we are conducting the reaction. This gets observed as a silver mirror. Then we looked at failings test. We're using a failings solution A and failing solution B mixed together as a reagent. This, when reacts with an aldehyde, there is a reddish brown coloration or a reddish brown precipitate that is formed, indicating that aldehyde is present in the given sample. We also looked at haloform reaction and who will give a haloform reaction, who will not. We said alpha methyl ketones give haloform reaction while others do not. Then we stopped at this concept. We spoke about reactions due to presence or absence of alpha hydrogens. Now we spoke about what alpha hydrogens are. The carbon that is bonded to the carbonyl carbon is called as the alpha carbon. If alpha hydrogens are present or absent, then we will look at certain reactions, is what we discussed. So why are we focusing on alpha hydrogens? We spoke about this too. Alpha hydrogens are acidic in nature. Now this is one very important conclusion that we need to know. Alpha hydrogens are acidic in nature. Now what do I mean by alpha hydrogens are acidic in nature? It means the hydrogens that are there at the alpha position can be easily abstracted by a base or can be easily taken away by a base as H plus. So this is the reason why whether presence of alpha hydrogen or absence of alpha hydrogen will give different reactions in the presence of a base. Clear? So they can be abstracted in the presence of a base, giving rise to a ion like this, giving rise to a carbanion, where there is a negative charge on the carbon atom. Clear? So this is something that we stopped at. We will continue with the reactions that we will be studying specifically with respect to presence or absence of alpha hydrogens. Let's look at the first one. Reactions due to the presence of alpha hydrogens. If I have any compound where there are alpha hydrogens, what is the reaction that happens? The reaction that happens is called aldol condensation. The reaction that happens is called as what? Aldol condensation. Now, very, very, very important reaction. Clear? This is something that is asked a lot of times. Explain aldol reaction or explain aldol condensation. Clear? You need to ensure that you understand it very, very clearly. Now, coming to the aldol reaction in the first place. Now, what is going to happen is I will take 2 moles of an aldehyde. Now, in this case, we are taking acetaldehyde. So, 2 moles of acetaldehyde in the presence of a base. Clear? In the presence of a base, OH minus. Now, we said this base can abstract what? Abstract an alpha hydrogen. Now, let us see if this compound contains an alpha hydrogen or not. Now, this is the carbonyl carbon. Yeah, so this is my carbonyl carbon. To the carbonyl carbon, I have a carbon attached. So naturally, yes. So this is the alpha hydrogen, the alpha carbon. So this is the carbonyl carbon. Do I have a carbon attached to that? Yes, I do. So this is the alpha carbon. So does the alpha carbon have hydrogens? Yes, alpha carbons do have hydrogens here, which means this base can abstract that hydrogen. This base can take away that H plus from a carbonyl compound. Clear? Now I want you to understand, I want you to observe the way in which we understand this reaction. This OH minus takes away H plus from here. Observe, this OH minus takes away H plus from here, which is nothing but the alpha hydrogen. Clear? If it takes away H plus from here, what will this species become? It will become negatively charged. CH2 minus is what it will become. Correct? Now, where will this species go attack? It will attack this compound. Now, where will it attack in that compound? The polarity is clearly defined. Oxygen is delta minus, carbon is delta plus. When I talk about the carbonyl group, the carbonyl group is polar. The carbonyl carbon is positively charged slightly, and the oxygen is negatively charged. Now, why is this happening? Because of inductive effect. This is something that we already understood a long time back. Oxygen is more electronegative, therefore it pulls electrons towards it, becoming delta minus, and carbon, since the electrons have moved away from it, will acquire a positive charge, delta plus. So now it is obvious that who will this negatively charged species attack? So this CH2 with a negative charge will attack this carbonyl carbon. I want you to understand this carefully. So this carbon having a negative charge will attack the carbonyl carbon. Now the moment it attacks the carbonyl carbon, it forms a bond. Now why can it form a bond? It can form a bond because there is a negative charge, and negative charge indicates two electrons. Two electrons are what are required to form a bond. So this carbon here forms a bond with the carbonyl carbon. The moment that carbon forms a bond there, what is the consequence? Yes, consequence is this carbon will have 5 bonds around it, which is not possible, which is not favorable in terms of stability. So what will happen? One of the bonds here will break, the pi bond. The pi bond between C and O will break, and those electrons will go on oxygen to become the negative charge. Clear? Got that? Will go on oxygen to become the negative charge. And is there H plus in the solution? Yes, because we just abstracted H plus, right? Now that H plus will come and bond with this oxygen. Clear? So the H plus that is there will come and bond with this oxygen to form the OH as indicated here. Clear? To form the OH, and this alpha carbon has attacked this carbonyl carbon to form this bond. Clear? Clearly you can see the alpha carbon mentioned here. So this is my alpha carbon, which is the CH2. So this is the alpha carbon. This carbon has attacked this carbon, which is the carbonyl carbon, and formed a bond. Now when you observe this, in this compound I have two functional groups. You have a CHO functional group, which is an aldehyde functional group. You have an alcohol functional group. Clear? When I combine these two, aldehyde and alcohol, what do I get? I get an aldol. I get what? I get an aldol. Hence the name of the reaction, aldol. Clear? Now the reaction says aldol condensation. Condensation means removal of water. So there will be removal of water. OH minus will be removed from here, and H will be removed from the alpha carbon here, and I get a double bond. Clear? Fine. So OH minus will be removed from here. H plus will be removed from here as water, and there's a double bond that gets formed, which is what is indicated here to give us but2-enal. Clear? But2-enal. So if this step happens, then it results in aldol condensation. Whereas if it stops at the first step, then it is called as aldol reaction. Clear? Yes. So very, very, very important. You need to understand what's happening here. So let me just breeze through this reaction once again for you. If an aldehyde or a ketone contains alpha hydrogens, clear? So there should be an alpha carbon, and to that alpha carbon I need to have alpha hydrogens. If alpha hydrogens are there, then they give a reaction called as aldol reaction or aldol condensation. Now what is aldol reaction or condensation? In the presence of a base, H plus is removed from the alpha position, or alpha hydrogen is abstracted. The moment it is abstracted, this species will become CH2 minus. Now this CH2 minus, or this entire molecule through CH2 minus, will attack the carbonyl carbon. Why will it attack the carbonyl carbon? Because the polarities are clearly defined in a carbonyl carbon. Carbonyl carbon is positively charged, oxygen is negatively charged due to inductive effect. So the moment it attacks the carbonyl carbon, it forms a bond with that carbon. Why will it form a bond? Because I have excess of electrons. I have two electrons in the form of the negative charge there. A bond gets formed. The moment the bond gets formed, there is a problem here. What is the problem? This carbon here will have 5 bonds around it, which is not favorable. So one bond is broken. Which bond is broken? The pi bond is broken. The pi bond between carbon and oxygen is broken and gets shifted on oxygen to become the negative charge. So this is again unstable. So it will abstract the proton that was removed previously. It will take away the proton that was removed previously to become OH. So this portion becomes OH as indicated. And the alpha carbon forms a bond with the carbonyl carbon of the second molecule, which is as shown here. So this is the bond that is formed between the alpha carbon of the first aldehyde and the carbonyl carbon of the second aldehyde. So a bond is formed and I get a product. Now when you observe the product, in this product there are two functional groups. Which are the two functional groups? Aldehyde functional group CHO and an alcohol functional group. An aldehyde and an alcohol together in a single compound is called as aldol. Clear? Now this aldol, if there is excess base again, can further undergo dehydration, removal of water. How is water removed? OH minus will be removed from here and H plus will be removed from the alpha carbon. Clear? Removed as water, and in place of that I have a double bond. A double bond is formed between the alpha carbon and the beta carbon to form an alkene. Clear? And it's an enal because I have a double bond and an aldehyde group. This reaction is called as aldol condensation. If it is only the first step where you get an aldol, then the reaction is called as aldol reaction. Very, very, very important reaction. Now, this reaction can also happen between two different compounds. Now, in the previous case, we looked at aldehyde, which is acetaldehyde. Here also I have acetaldehyde and I have a ketone. Now, can this ketone undergo aldol condensation? Yes, it can. Why it can? Because what is the only condition? The only condition is I should have alpha hydrogens. Now, this has two alpha carbons. In fact, it has more alpha hydrogens than this aldehyde. So this also can give rise to an aldol reaction. Clear? Now I have four products mentioned here. Now these two can combine to form four products, which is as shown. I want you to observe this slide for a couple of minutes, observe the products and try to see how is it possible for us to get two different products. I want you to observe and then we will continue. I'll keep the slide open so that you can understand better. Try to see how you get 1, 2, 3, and 4 products. Got that? Are you able to figure out how there are 4 products? Okay, let me give you a hint. Now, let's look at this compound. So this compound, does it have alpha carbon? Yes, it has. Does it have alpha hydrogens? Yes, it has. I can have 2 moles of this reacting on its own. It can react with 1 more mole of acetaldehyde. So if this acetaldehyde reacts with 1 more mole of acetaldehyde, I get 2 products. As mentioned in the previous slide here, if 2 moles of acetaldehyde react, here I get 1 product, correct, as shown. So 2 moles of acetaldehyde will react to give 1 product. Okay, so likewise I can have 2 moles of ketone reacting, correct. So 2 moles of ketone can react to give me 1 more product. Clear? So that makes 2 products out of the 4. Then what about the other 2? Yes, other 2 is 1 mole of aldehyde reacting with 1 mole of ketone. If hydrogen is removed from aldehyde, then I get the third product. If hydrogen is removed from the ketone, then I get the fourth product. Clear? This is not in terms of 1, 2, 3, 4 here, but I'm just talking about the number of products. You understand? So let me repeat once again. If 2 moles of acetaldehyde react on its own, with itself, then I get 1 product, just like what we saw in the previous slide. Likewise, 2 moles of this ketone, which is acetone, also can react to give us 1 more product. The third product is obtained when acetaldehyde reacts with acetone and hydrogen is removed from acetaldehyde. The fourth product is obtained when an acetaldehyde reacts with acetone and the hydrogen is removed from acetone. Clear? So depending upon where hydrogen is removed from which compound hydrogen is removed from, and which compound is attacking the other carbonyl compound, I get the other 2 products. Got that? So I want you to practice right now. So I have this reaction kept in front of you. I want you to practice and see whether you get all these 4 as the products, depending upon whatever we have spoken right now. I'll just give you 2 more minutes so that you're able to write it. Now, I want you to do it right now, because if you do it and you get a hang of it, you'll be in a better position to understand and reflect on this reaction. Write it. You should have got 2 products so far. Write down the reactions for the other 2. Done? All right. So just understand right now. You can anyways write it whenever you are free, whenever you would like to practice. Now let's look at the first case. If I take 2 moles of acetaldehyde, if I just take 2 moles of acetaldehyde, from one of them I remove H plus. From one of them I remove H plus. Therefore, CH2 minus will attack the carbonyl carbon of the other aldehyde to give us which of these products here? Can you guess which of these products? Yes, it is product 1. Here, if hydrogen is removed, so this is obtained when, let me try to write it, and I'm using a mouse to write these structures. It is very difficult, but I'll try to ensure that you understand. Clear? So this is what I have. If I have 2 moles of acetaldehyde reacting, if hydrogen is removed from here, clear, this CH2 minus will attack this carbon, correct? So this CH2 minus will attack this carbon to form a bond. The moment a bond is formed, valency is not satisfied, so pi bond breaks and goes on oxygen, and the negative charge that is created will take away the abstracted hydrogen. So this will become OH as indicated here, clear? And this CH2 has attacked this carbon to form this bond. Clear? Which is what is shown here. So the CH2 from the second molecule forms a bond with this carbon, which is indicated here, giving us the first product. Clear? Then look at the second product. Now, who might or who would have given this product? Now, when you observe closely, this is an aldehyde group. Clear? This is an aldehyde group, which is an aldol. An aldol will be obtained when, of course, one of the starting compounds is an aldehyde. Clear? If the starting compound is an aldehyde, then you will definitely get an aldol. You will have an aldehyde group and an alcohol group. Now look at this compound here. Do you see an aldehyde functional group anywhere? No, you don't. Instead, what do you see? You see a ketone and the alcohol. I can call this as ketol. I can call this as what? Ketol. Now you look at this ketol. Can you get it from 2 moles of acetaldehyde? No, not possible. Can you get it when acetaldehyde, one molecule reacts with one molecule of acetone? No, not possible. Clear? This ketol is obtained when 2 moles of ketone react. So this ketol is obtained when 2 moles of ketone react, 2 moles of acetone react, just like what we did here. Here, instead of taking acetaldehyde and acetaldehyde, if you take 2 moles of ketone, you will get this product. If hydrogen is removed from one of them, that resultant ion will attack the carbonyl carbon of the second compound to give us this ketol. Clear? Got that? All right. So this is the second product. And let's observe the third product. Now, when will you get this product? Now this is also a ketol. This is also a ketol. But what is the difference between this and this? Yes, in this, I have an extra CH3 group as a substituent. Clear, indicating that both of them is obtained from ketone. Whereas you look at this, do I have a do I have a CH3 group as a substituent? No, I don't. Which means this product is obtained when 1 mole of aldehyde reacts with 1 mole of ketone, and hydrogen is removed from the ketone. Clear? So let me repeat. This product here, product number 3, is obtained when 1 mole of aldehyde reacts with 1 mole of this. And where is removal of H plus from? H plus is removed from the ketonic part. Therefore, the ketonic part becomes CH2 and forms a bond with the carbonyl carbon of the aldehyde, giving us the third product. So naturally, when do I get the fourth product? The fourth product is again when the aldehyde reacts with a ketone, but the hydrogen is removed from the aldehyde. When the hydrogen is removed from the aldehyde, this will become CH2COH, CH2COH, which will form a bond with the carbonyl carbon. Clear? Got that? Yeah. So this is what is the fourth product. Now I want you to look at this compound here. Here I want you to look at this compound and tell me what is the mistake in this compound. There is an error. There is an error in that compound. Find out what is the mistake. Let me see how many understand the basics of organic chemistry. Now the question is not difficult. The answer is not difficult too. It's just that you need to understand the basic concept. If you know the fundamentals, you'll be able to answer this. So what is the mistake? What is the valency of carbon? 4, correct. What do you mean by valency of carbon is 4? Yes, there are 4. There should be 4 bonds around it. The mistake lies with this carbon here. Now, how many bonds are there attached to this carbon? 1, 2, 3, 4, and one more bond with this hydrogen. Is it possible? No, not possible. So this is the mistake. So this hydrogen should not have been there. Got that? These are small things that you should immediately pick it up. And I know it's difficult initially, but you need to spend time on the reactions. The moment you spend time, you are try to apply the fundamentals and basics. It'll be very easy for you to pick up these small things. Clear? Got that? Yeah. So now you understand how you get 4 different products. Clear? If the compound reacts with itself, the same compound reacts with one more of its same kind, then you get one product. If it reacts with the other compound, depending upon where the hydrogen is removed from, H plus is removed from, you get the other 2 products, and the fourth product will be again between itself. If 2 same aldehydes or if 2 same ketones combine to form an aldol, then such an aldol is called as a self-aldol reaction. What is such an aldol called as? Self-aldol reaction. Same thing applies to a ketone as well. If 2 ketones, which are the same, react in the presence of a base, you call this as self-aldol. On the other hand, if 2 different carbonyl compounds, as in the case that is seen here, if 1 mole of acetaldehyde reacts with 1 mole of acetone, if 2 different carbonyl compounds combine in the presence of a base, then the reaction is called crossed aldol. This is a very important concept. Let me repeat it once again. If two same carbonyl compounds, it can be either an aldehyde or a ketone, combine in the presence of a base, then the aldol reaction is called self-aldol reaction. If two carbonyl compounds which are different combine with each other in the presence of base, then the reaction is called crossed aldol reaction. Now, whatever is mentioned in this slide here, you have four products. Two products are formed because of self, two products are formed because of crossed aldol. Now, can you identify which are the products formed because of self aldol and which are the products formed because of cross aldol? Yes, product 1 and 2. Products 1 and 2 are formed because of self. Product 1 is formed when two acetaldehyde reacts. Product 2 is formed when two acetone molecules react. So both of them come under the type self-aldol reaction. Whereas product 3 and product 4 is obtained when 1 mole of acetaldehyde reacts with 1 mole of acetone. Depending upon where the hydrogen is removed, you get two products. Such reaction is called crossed aldol. Clear? So now do you understand the difference between self-aldol reaction and a crossed aldol reaction? All right, good. Now this is one more example. Now I want you to take this as homework. Clear? Don't look at the products here. I want you to take this as homework. Instead, probably I'll do one more thing. Take ethanol and propanol. Take ethanol and propanol. I'll just keep the slide open. I thought I'll just dismiss the slide, but anyways, I trust that when you do the homework, you will not look at the slide. I want you to take ethanol and propanol. These are two aldehydes which have alpha hydrogens, so therefore they will give aldol reaction. And I want you to carry out both self-aldol condensation and crossed aldol condensation. So I want you to carry out both self-aldol condensation and crossed aldol condensation. Clear? You should get four products. It's all mentioned here in the slide, but I want you to be honest. When you are doing the homework, try to write it without looking at the slide, just copying it. Try to understand, try to see whether you got hold of the concept. Practice it. Once you're done practicing, then you can look at the slide. You can look at the slide and then verify whether what you've got as products are correct or not. Clear? Yes. So the moment you do this exercise, you will be in a better position to understand whether you've understood self-aldol or crossed aldol. Very, very, very important reaction. So once you have done that as homework, tomorrow we will continue with this. Clear? I'll just explain how you got each of these. Clear? All right. Now we said if alpha hydrogens are present, then the reaction is called as aldol. What if alpha hydrogens are absent in the presence of a base? The reaction Cannizzaro is what is seen. So when two aldehydes are ketones, without alpha hydrogens, they should not have alpha hydrogens. If they do not have alpha hydrogens and they react with a base, then they don't give aldol condensation. Instead, they give a reaction called as Cannizzaro's reaction. Very, very important. One more. Clear? All name reactions are important. Fine. Now let's look at what is Cannizzaro's reaction. In terms of an example, even here, two molecules of an aldehyde or a ketone will react. Let's look at the aldehyde here. This aldehyde is formaldehyde. Now, your first task is to find out whether alpha hydrogens are absent or not. Now, which is the alpha carbon? In this compound, I do not even have an alpha carbon. Can you see that? I don't even have an alpha carbon. Who's an alpha carbon? Carbon that is attached to the carbonyl carbon. When I don't even have an alpha carbon, will I have an hydrogen? Not at all. Hence, this will not undergo aldol reaction. Formaldehyde will not undergo aldol reaction because it does not have alpha hydrogens. Instead, when 2 moles of formaldehyde react with the same reagent, which is a base, it undergoes Cannizzaro reaction. Now, what is Cannizzaro? Observe the reaction. When 2 moles of formaldehyde react, we get methanol and potassium formate. We get what? We get methanol and potassium formate. So I get an alcohol and a salt of carboxylic acid. So we get what? We get an alcohol and a salt of carboxylic acid. If I take potassium hydroxide, I get the potassium salt. If I take sodium hydroxide, I get a sodium salt. Clear? Now, one very important aspect of this reaction is when 2 moles of aldehydes are reacting, I am getting an alcohol and a carboxylic acid. Now, by now we have understood aldehydes upon oxidation will give what? Carboxylic acid. Aldehydes upon reduction will give what? Alcohol. So this is a reaction where you get two products. One is formed because of oxidation and the other one is formed because of reduction. So if I have to explain with formaldehyde, 1 mole of formaldehyde gets oxidized to form carboxylic acid. The other mole of formaldehyde gets reduced to form alcohol. So out of 2 moles, one compound undergoes oxidation to form the potassium salt. The other aldehyde gets reduced to form an alcohol. Such a reaction is called as disproportionation reaction. What is such a reaction called? Disproportionation reaction. What is a disproportionation reaction? A disproportionation reaction is a reaction where out of 2 molecules, one of them will undergo oxidation to give the final product. The other one will undergo reduction to give the final product. You got that? So very important. Cannizzaro's reaction is an example for disproportionation reaction. Let's look at the second example. Second example is benzaldehyde. Now, does benzaldehyde have alpha carbon? So this is my carbonyl carbon. I have an alpha carbon, so this is an alpha carbon. But the reaction is not with respect to alpha carbon. What is it with respect to? Yes, it's with respect to alpha hydrogens. Does this carbon, alpha carbon, have hydrogens? No, it does not. Hence, this compound also, benzaldehyde also, will not give aldol condensation with a base. Instead, it will also give Cannizzaro's reaction. So when I take 2 moles of benzaldehyde, now we know the logic of Cannizzaro's, it is disproportionation, which means 1 mole will undergo oxidation, the other mole will undergo reduction. So depending upon which is undergoing oxidation and which is undergoing reduction, you get the oxidized product or you get the reduced product. Now, when benzaldehyde reacts in the presence of concentrated NaOH through Cannizzaro's, you get benzyl alcohol and sodium benzoate as the product. Now, even here you can clearly observe one of the moles of benzaldehyde is undergoing reduction to give alcohol. Another mole is undergoing oxidation to give the sodium salt of benzoic acid. Clear? Hence, justifying that this reaction is disproportionation reaction. Clear? So this reaction is called Cannizzaro. Just like what we studied in the previous reaction, if 2 moles of formaldehyde react with each other, then the reaction is called as self-Cannizzaro reaction. What is it called? Self-Cannizzaro reaction. When 2 moles of the aldehyde which are same, which react with each other. Likewise, if 2 moles of benzaldehyde react with each other, then once again the reaction is called self-Cannizzaro reaction. If 1 mole of formaldehyde reacts with 1 mole of benzaldehyde, then it is called as crossed Cannizzaro reaction. If 1 mole of formaldehyde reacts with 1 mole of benzaldehyde, we get crossed Cannizzaro reaction. And just like the previous case, if I take 2 moles, one of formaldehyde and one of benzaldehyde, you get 4 different products. Clear? Depending upon who is undergoing self and who is undergoing crossed. Clear? So homework for you. I want you to write the crossed Cannizzaro reaction between formaldehyde and benzaldehyde. I want you to write crossed Cannizzaro reaction with formaldehyde and benzaldehyde. Clear? So take that as homework. Now, one of these two reactions is very, very important. It will come in your exam. If Cannizzaro is asked the first year, Aldol is asked the next year, and subsequently it follows the pattern. So very important, make it a point you understand these two reactions. Both of these reactions are based on alpha hydrogens, whether it is present or whether it is absent. If alpha hydrogens are present, then in the presence of a base, aldol reaction happens. If alpha hydrogens are absent, in the presence of a base, Cannizzaro reaction happens. Clear? All right. Let's look at the next type of reaction, which is called electrophilic substitution reaction. Now, this is one common reaction with all aromatic aldehydes and ketones, whether it is whatever be the functional group. If some compound is aromatic, it will definitely undergo electrophilic substitution. This is something that we have been seeing right from last year, right from when we studied benzene to chlorobenzene to phenol to now. In all the cases, electrophilic substitution is one of the characteristic reactions of all aromatic compounds. Now, just like what we did in the previous chapter, we need to identify what is the nature of that carbonyl group which is attached to benzene. Depending upon what is its nature, we can guess where the electrophile will go, whether it will go to ortho position, whether it will go to para position, or whether it will go to meta position. Now, in all the previous cases that we studied, we looked at chlorobenzene and we looked at phenol, right, in the previous two chapters. In both the cases, the products were ortho and para in nature. Now, why were they ortho and para? Because the groups were electron releasing in nature due to the presence of the lone pair. Now, any electron releasing group attached to benzene will increase electron density at ortho and para positions. They are also called as activating groups. They activate the ortho and para positions with electron density. Therefore, the incoming electrophile is always directed towards ortho or para positions. The incoming electrophile is always directed towards what? Ortho or para position. to give us ortho and para products. Let's understand what's happening in the case of carbonyl compound. A carbonyl group is an electron withdrawing group. Very, very, very important. A carbonyl group is an electron withdrawing group. Because it is an electron withdrawing group, it pulls electrons from the benzene ring. And when it pulls electrons from the benzene ring, it pulls more electrons from ortho and para positions. It pulls more electrons from where? Ortho and para positions. Therefore, where is electron density high? Electron density is high at the meta position. Since electron density is high at the meta position, the incoming electrophile will be directed where? Yes, it will be directed towards the meta position. Hence, we get meta products. Got that? So this is one difference in carbonyl compounds with the other two compounds, haloarenes and phenols that we saw. Haloarenes and phenols gave us ortho-para products, whereas carbonyl compounds, be it an aldehyde or a ketonic group that's attached to a benzene ring, they will give us meta products because the carbonyl group is a meta directing group. Clear? I've given two examples for you. When benzaldehyde reacts with nitrating mixture, whose nitrating mixture? An equimolar mixture of concentrated nitric acid and concentrated sulfuric acid. A nitro group gets substituted in place of hydrogen at the meta position, giving us meta nitrobenzaldehyde. Clear? So this example is of nitration. I've given you one more example for sulfonation. Sulfonation of benzaldehyde gives us sulfonic acid group attached at the meta position. Clear? This is a clear difference between aldehydes and ketones and haloarenes and phenols. Clear? Same thing is observed in Friedel-Crafts reaction, Friedel-Crafts alkylation and Friedel-Crafts acylation as well, where the products will be meta, and same thing is observed in halogenation as well. Halogenation is the other electrophilic substitution. The products will be at meta. So I want you to take these two reactions as homework. Friedel-Crafts reaction, I want you to carry out Friedel-Crafts reaction and halogenation of benzaldehyde. So take benzaldehyde, start with benzaldehyde, carry out Friedel-Crafts reaction. Clear? With this, we are done with all the chemical properties of aldehydes and ketones. We will stop here. I've given you significant homework for today's class. Finish the homework and submit the same. Next class, we will start with the chemical properties of carboxylic acids. Clear? So until the next class, thank you. Namaste.